In this video, we're going to take a look at condensation reactions. And just like it sounds, condensation, right? When we think of that, we think about water forming, right? Liquid water forming. Same idea. We're going to see water formed during a condensation reaction. So this reaction is used quite a bit. We do it to create esters, right? A functional group in our organic molecule. We can use it to make amides. We can use it to make ethers. There's a number of different condensation reactions that can take place. Again, like previous, we're not going to focus on sort of all the mechanics of how the electrons are moving and things like that are causing this reaction to occur. We are just simply looking at, can we recognize when a condensation reaction is going to take place, what the potential product would be, and where those new bonds end up being formed. So that's what we're going to look at in this particular example here. So in my first example, I'm using an alcohol, right? This is methanol. And methanol, when it reacts with a carboxylic acid, which is the functional group we see right in this molecule right here, the C double bond O with the OH attached. This is propanoic acid. When we see a reaction take place between an alcohol and a carboxylic acid, we can actually make an ester functional group from this particular reaction. And when we look at it, what we tend to see is that for a condensation to occur, we need to form water. And the key with the condensation reaction is that a piece of the water is coming from each of the molecules. So for instance, our OH from our carboxylic acid and the hydrogen from our alcohol. And when we take a look, those two pieces can come together. That's what's going to make the water. And then what it leaves is a bond right from this carbon right here, this bond that needs to be made now to, in this case, my oxygen that's over here, right? And so that's where we're going to get this ester created. And so when we do the reaction, we will end up producing this particular ester, right? So that new bond formed between the oxygen and carbon right here. And then we've got the C double bond O, and then we finish the rest of our molecule. And the other byproduct then has to be a water molecule that's produced, right? So we end up producing this ester. And if you're getting into naming esters, this one would be called methyl propanoate. So you'll notice the name from the, oops, I forgot the Y. The name from the alcohol component comes first, the part off the oxygen, and then the remaining part of the molecule is named with the O8 ending. But how we recognize that condensation reaction, we get a piece of water produced coming from each of those reactant molecules. We get that water product formed, and we form this beautiful ester functional group, which we see right in here. Right, that new functional group has formed. That's our ester. Okay, so this is our creation from a condensation reaction. We can use an alcohol and a carboxylic acid, and we'll make an ester. Right. Another example, just for fun, is using an amine like we have here, CH3NH2. So this particular amine, this is aminomethane. Okay, and we're reacting with this carboxylic acid, which is ethanoic acid. And again, for your purposes, naming these things might not be what you're focused on. You're just focused more on the reaction that's taking place. So we want to look at how a condensation reaction is going to take place. Well, we know it has to form water. So we need OH and we need H. And if we look, the only place the OH can come from is from the acid. So that part's going to be removed. And then our hydrogen from the amine piece, from the nitrogen piece, is going to be removed, right? And they're going to come together to form that water byproduct. And in the process, they're going to create that linkage that we're going to see from the carbon to the nitrogen, and they're going to create an amide. They're creating an amide linkage. So when we create this molecule, redraw it here with that new bond in place, we see this bond forming, the N to C forming, where that C double bond O is located. and this is our molecule, and we get that water byproduct. So in this case, we've made this amide functional group right here, right? So we've made an amide in this case, which is pretty cool. And that's done through a condensation reaction. Now, if you want to be able to name this, this is N-methyl, and then a space for the rest of the name, and it would be ethanamide. Okay. But as I said, for the purposes of what I'm looking for, what we're looking for with these condensation reactions is that you're recognizing where the new bond forms to create that new functional group, where those OH and H are coming from to create that water, and to be able to look at the reaction and recognize, hey, that's a condensation reaction, right? If water gets created as a product and parts of the water come from separate reactants, we're getting a condensation reaction. And you see this one a lot in nature. The reaction between the amide, the second example here, the amine, and the carboxylic acid producing the amide, we see that all the time, right? When especially in biological systems where you're making amide linkages and peptides and things like that with amino acids. Esters in fabrics and things like that, polyester, found all over the place. So condensation reactions are a very, very useful tool, very useful reaction in chemistry. And hopefully you get the chance to try some of these in a lab sometime.